Good evening, everyone. Myself Gautam Sharma. I welcome you all in a Sapience Education. So, for more information, please visit our website www.sapienceeducation.com. So, today I'm going to discuss about the alternating current, and that in that I will discuss about the average power of the alternating current in the LCR circuit. So, this is part 6 video. For more information, for more topics, you can visit our previous parts of the LC current. No average power in RLC circuit. Let us consider average power in mostly we have resistance, inductor, and capacitor circuit. So in any circuit, this three thing you will get. Now let us consider our our EMF. EMF is given as E naught sine omega t, and then current as per we have already found the current. So current is equal to sine omega t minus phi, where phi is the phase difference. Current here, current is current is lagging lagging by an, by pi angle. Okay. Now let us try to understand why we need to find the average power. So I will give you some of the graph that power. We know that power has a formula EMF into current. Now let us consider there is a wave diagram. So let us consider this is as a wave diagram. In this, there are two axes and it has, and in this what happens, current is like by pi. So let us current is lagging by pi. So current, it has current diagram, like current diagram will be like this, right? Now I want power. So how we can calculate the power? Every time current as well as voltage both are both are changing. So for this case we need an average power. So we can only find average power over a time period of a capital T, that is one cycle. So average power, right? So how to find the average power over a over a 0 to time period T? So here average power in 0 to T time period cycle, that is one cycle. So for over one cycle. Now if we talk about the instantaneous power, so instantaneous power will be equal to EMF, instantaneous EMF into instantaneous current. Now, if we put here the value, so this we will get as P naught sine omega t into I naught sine omega t minus phi. Okay, so this is an instantaneous power. We don't have a overall power, or we don't have an average power. So instantaneous power can also be written as the work done or energy taken per unit time. So this equation can be written like this. Now I will rearrange the equation so that total energy consumption over a time period we can get. Work done or work done W can be considered as the total energy consumption over a time period T. Now the total energy consumption over a time period of t. So it can be written as it can be written as dw can be written as E naught sine omega t I naught sine omega t minus phi n into dt. Now we need an energy consumption over a time period of t. So integrating both the side. So we can integrate both the side. Integrating both the side. Integrating both the sides. So we get both side. If I will integrate both the sides, so what we will get? Integration of dw. This is equal to integration of e naught sine omega t I naught sine omega t minus phi into dt. Now from here we will get total energy consumption, that is W can be here we will use the integration. Now we want integration over a time period of capital T, that is for over a complete cycle. So here first of all, what are the constant? So we should keep all the constant one side. So E naught and I naught are the constant term, and from 0 to time period t. Now this is your sine omega t into sine omega t minus phi. So sine omega t minus phi can also be written as sine omega t minus phi. So sine a minus sine b can be written as sine a cos b minus cos a sine b. Right? So from here we can write here sine omega t cos phi minus cos omega t sine phi, and this whole is integrated under the dt. So from here E naught, again E naught I naught, 0 to time period t. Here we can write sine cos phi sine square omega t minus integration of 0 to t. Just I am breaking the integration. So here we will get as sine phi into sine omega t into cos omega t into dt. So from here also we should keep dt. Now from here, what we can do is that this is cos phi. So this see E naught I naught is common for all. So from here, what we can write E naught I naught cos phi. Cos phi is constant because phi is the phase difference. So we can take out cos phi. So from here we can take as a cos phi. So let us take it out as a cos phi. And sine square omega t can be written as 1 minus cos 2 omega t divided by 2, right? And we should integrate from 0 to time period of t into dt minus. Here sin phi is constant. Sin phi is constant. So from over a time period of 0 to time period t, can we write here sin omega theta into cos theta can be written as sin 2 omega t by 2 into dt. So still we have not yet integrated. Now we need to integrate it. So what should we do? Now next slide. First of all, what should I do? Write E naught. We should write root of both of them is equal to E naught I naught. After that, bracket cos phi. First of all, take a big bracket. Then again you need to find cos phi and cos phi. After that, 0 to 1 time period t. So cos phi by 2, can we take out 2 as a common? So here cos pi by 2 we can take as a common because it is a constant. After that 1 minus cos omega t. So integration of 1 you know that integration of 1 will be t minus integration of cos 2 omega t can be written as cos theta is equal to integration of cos omega t can be written as sin theta. So this can be written as sin 2 omega t divided by 2, and the limit, again the limit which is being put here is from 0 to time period t, minus again we can take here from this sine sine pi by 2. So from here we can write here sine pi by 2, sine pi by 2, and after that integration of sine 2 omega t can be written as integration of sine 2 omega t can be written as cos 2 omega t. So from here we can write here cos 2 omega t, and there will be a negative sign. So it will let it be 2 omega, and there will be negative sign, so it will become positive, and our limit will be from 0 to time period t, right? So overall bracket is closed. Now the thing is that we need to put the values. And one more important thing is that we need to understand. Uh, we need to understand that omega omega is equal to 2 pi by t. So from here t omega can be written as 2 pi. So limit, we need to first of all put the limit. So from here just I can combine here. We can write here e naught I naught by 2 cos phi, and if you put here t minus 0, so finally you are getting t minus, again you tell me sine omega t minus 0. So here you will get as sine 2 omega t capital T divided by 2 minus 0. So finally we have got this plus. I will take here also e naught sine e naught I naught. Let us consider e naught I naught by 2 e naught I naught by 2 sine phi. So let 2 sine phi, and this is cos 2 omega t by minus, and can I take here 2 omega common, so this will become 4 omega. So from here cos omega t minus cos 0 will be cos 0, right? So these are the suitable example. Okay, now tell me sin omega t. See here t omega can be written as 2 pi. So from here e naught I naught divided by 2 cos phi. Now t minus sine 2 omega. T omega can be written as 2 pi. So this will be sine 4 pi by 2 plus e naught I naught by 4 omega sine pi. Now from here t omega can be written as 2 pi. So this will become as cos 4 pi. Cos 4 pi minus cos 0, that is 1. Now you know that cos 4 pi will be 1, and this will be 1. Cos sin 4 pi has a value of 0. This will become 1. So this whole term will become 0. So finally what we will get? We will get as E naught I naught divided by 2 cos phi into t. Rest will become 0. So this is work done. Now what we want a work done or total energy consumption. Now we want average time period or average power. So if you want average power, so what should you do? So average power P average is equal to total energy consumption divided by time t. So from here we will get as E naught I naught divided by 2 t cos phi into t. So t got cancelled out. So finally we have got the value as average power as E naught I naught divided by 2 cos phi. So this is our average power, right? So this is the average power. One more important thing, we can write average power. So finally we have got average power. Now we can also write average power as, see here, P average. Can you understand this? P average can be written as E naught by root 2 into I naught by root 2 into cos phi. So E naught by root 2 is your our PRMS. So ERMS into IRMS into cos phi. So this is the value of average power. So from here we can get average power like this. So average power is equal to this, right? I hope you have understood this is an average power consumed by RLC circuit. This is an this is an average power consumed by the circuit for a time period of t or one cycle. For one cycle, we have calculated for one cycle, right? You can also calculate it for enormous, depend upon this. Now, average power depends upon P average, depends upon depends upon cos phi, right? This cos phi is considered as a power factor. This cos phi is considered as power factor. Power factor. So from here we can also write cos phi as P average divided by ERMS IRMS. So I hope you have understood this. Okay. So you can write this. We can write this. Okay. Now power consumption is maximum when cos phi is zero. One more important, when cos phi is equal to zero, cos phi is equal to one, power consumption is zero. That is phi is equal to one. When phi is equal to one, so the power consumption is maximum. Power consumption is maximum. Okay, so this is what we have already done. So if you have any doubt, you can go. Now we will discuss about the conditions of the average power for each and every circuit. So first condition for average power, let us consider average power for resistive circuit. P average for resistive circuit. Resistive circuit. Now we know that P average is equal to ERMS IRMS into cos phi. That is phase difference. We have already seen that in resistive circuits, if it is your E naught and if it is your I naught, so the angle between this that is equal to phi is equal to 0. So when phi is equal to 0, so P average is equal to ERMS into IRMS into cos 0. Cos 0 will become 1. So this is for resistive circuit. So when only resistance is there, when only resistance is there, right? Now case 2. So this is first case. When we need an average power for purely inductive or purely inductive or capacitive circuit, right? So if you want to find a purely power average power, so first of all you need to understand that what is the phase difference. In inductive circuits, we have seen that current was lagging by pi by 2, that is phi is equal to pi by 2. And in capacitive circuit, current is being ahead by pi by 2. So in both the case, phase pi is pi by 2. So average power for inductive or capacitive circuit is equal to ERMS into IRMS into cos 90. So this will be 0. So I hope you have understood that in the average power for inductive as well as capacitive circuit is 0. Right? Now, next case is your power dissipation in a average power in case of resonance conditions. resonating condition we have earlier seen that XL is equal to XC. XL is equal to XC, right? So XL is equal to XC. So from here we know that the phi for the RLC circuit, in RLC circuit, XL is equal to Xc, then the conditions are resonating condition, and in this condition, if we want to find a phi, so phi is equal to tan inverse Xc minus XL divided by R. So XL and Xc both are same, so it can be written as 0. So from here we have 0. So average power for a resonating condition is equal to IRMS into cos 0. So this will become maximum. So this is the maximum value. What do you mean by this? When there is a resonance condition, so there is a maximum flow of a current. So that means that there is a maximum power dissipation. So I hope you have understood this power, average power for each and every circuit. So thanks for watching my video. If you want any type of a query, if you want to ask anything, just you can put message, comment to us so that you can get each and every query to be rectified. Thank you for watching my videos.